Isang math-sayang araw sa inyong lahat. Math-sayang araw, Sir Jonathan.
Math-sayang araw, Sir Roy.
Kami ang Team Ilaya Barangka Integrated School. Gurong Ilaya, magaling yan! Sa ating OIC SDS, Dr. Romela M. Cruz, Sese.
Sa aming OIC ASDS, Dr. Aurelio G. Alfonso.
Sa ating SGOD Chief, Ginang Emma G. Arubio.
Sa aming CID Chief, Dr. Aline G. Mendoza.
Sa aming napakasipag na Education Program Supervisor, Mr. Resty I. Rodelas.
Sa aming Dear School Head, Mr. Joseph B. Alegre.
Fellow teachers, Mandunong Kids,
Home Learning Partners.
at sa iba pang nanonood sa atin ngayong araw na ito. Muli, isang math-sayang araw sa inyong lahat.
Welcome to Project SOAR Week 5.
Series of online academic reviews of mathematics CLAID learning modules.
I am Mr. Jonathan P. Roman, a grade 8 mathematics teacher.
And I am Mr. Roy P. Haldalso, a grade 6 mathematics teacher. And we are your MCs for today. Para sa lahat ng nanonood sa atin ngayon, please do not forget to follow our official Facebook page, Math Team, Mathematics Teachers Association of Mandaluyong,
And subscribe to our YouTube channel, MTM channel, para maging updated ka sa mga programs and activities ng mathematics.
Bago natin simulan ang ating review session ngayong umagang ito, hingan muna natin ng mensahe ang aming napaka-supportive at napakasipag na school head ng Ilaya Barangka Integrated School. Ladies and gentlemen, Mr. Joseph V. Alegre.
Good day everyone. We welcome you to Ilaya Barangka Integrated School Project SOAR or Series of Online Academic Reviews in Mathematics. Today, we are going to serve you with several reviews from elementary to senior high school. We do hope that our endeavor will greatly contribute in understanding basic mathematics to complicated mathematics, and hopefully you will enjoy what we prepared for all our learners and to other learners in the Philippines and around the world. Good day and enjoy! Mabuhay ang Pilipino. Gurong Ilayans, magaling yan. Gurong Ilayans, matgaling yan.
Maraming salamat, Sir Alegre, para sa napakagandang mensahe sa umagang ito.
Sir Jonathan, alam ko kanina pa excited ang ating mga learners kasama ng kanilang home learning partners para sa advanced lessons ngayong araw na ito.
Tama ka dyan, Sir Roy. Sino ba makakasama natin for grade 7? Our teacher reviewer for grade 7 is a graduate of Bachelor of Secondary Education at University of Makati, formerly known as Pamantasan ng Makati, in the year 1995. He earned a 39 units in Master of Arts in Teaching Mathematics at Philippine Normal University. He was also a high school teacher of Sacred Heart Institute in Muntinlupa in the year 1995 to 1997. A high school teacher and coordinator of student affairs at Namay Polytechnic Institute from 1997 to 2015, and later became a part-time instructor in the College Department of Namay and STI Santa Mesa in the year 2009 to 2019. Currently, he is a grade 7 mathematics teacher at Ilaya Barangka Integrated School since 2015. Our teacher reviewer for grade 7, Mr. Jomy D. Ocampo.
Thank you, Sir Jonathan Roman, for that wonderful introduction. Good afternoon, Mandunong students, and to all our home learning partners. Again, I am Mr. Jomy de Los Santos Ocampo, and I will be your teacher reviewer for the advanced lesson of week 5 for grade 7. Get ready with your modules, pen and paper for our discussion later on. So, let's start. Tayo ay nasa quarter 2, week 5. At ang topic ko sa hapong ito ay ang laws of exponents. Allow me to read the competency of the lesson. The learners derives the laws of exponents. Here is the objective of this lesson. The learner should be able to apply laws of exponents. Here is some of the concept of the lesson. First, we have the exponent. It is a small number placed on the upper right portion of a variable or an expression. It also tells you how many times the base is used as a factor. It is the convenient way of writing repeated multiplication. The base means the number or variable that is being multiplied repeatedly in the expanded form. Here is an example. Our first example is 8 times 8 times 8 times 8 times 8 can be expressed as 8 to the 5th power. So, our base is 8 and our exponent is 5. Example number 2, you have 5 times 5 times 5 times 5 times 5 times 5 can be expressed as 5 to the 6th power. So, our base is 5 and our exponent is 6. Example number 3, we have 10 times 10 times 10 times 10 times 10 times 10 times 10 and times 10. So we multiply 10 8 times. So we can express that one in exponential form as 10 to the 8th power. So 10 is our base and 8 is our exponent. Before we proceed with the different laws of exponent, let's have first a short review of the previous module. Letter A, give the value of the following exponential form. So let's take a look with example number 1. So you have 6 squared is equal to 6 times 6, which is equal to 36. Example number 2, so you have 4 cubed. It means we're going to multiply 4 3 times. So you have 4 times 4 times 4 is equal to 64. Number 3, you have 10 to the 6th power. It means you're going to multiply 10 6 times. So 10 times 10 times 10 times 10 times 10 and times 10, which is equal to 1 million. This time, let's simplify the following exponential form. 3 to the 4th power divided by 3 to the 2nd power. What we're going to do is we're going to expand first 3 to the 4th power and 3 to the 2nd power. So 3 to the 4th power is equals to 3 times 3 times 3 times 3. Then 3 squared is equals to 3 times 3. Then we're going to cancel out the 2 3's in the numerator and the 2 3's in the denominators. So the remaining 3's are 3 times 3. So 3 squared is equals to 3 times 3, which is equals to 9. Example number 2. You have 8 cubed multiplied by 5 squared divided by 8 times 5. So we're going to expand 8 cubed multiplied by 5 squared, which is equals to 8 times 8 times 8 times 5 times 5 divided by 8 times 5. Then we're going to cancel out both numerator and denominator, 8, and then 5 and 5. So the remaining numbers are 8 times 8, which is equals to 64, then multiply by 5 is equal to 320. Next, we have example number 3. So you have 9 to the 4th power divided by 9 to the 4th power. So therefore, if we're going to expand 9 to the 4th power, that will become 9 times 9 times 9 times 9 divided by 9 times 9 times 9 times 9. Then we're going to cancel out the 4 9s in the numerator and 4 9s in the denominator. So that will be equal to 1. Let's have letter C. Let's identify the base in the exponent in the following expressions. So let's take a look with number 1. So you have 15d cubed. So our base is letter D. And our exponent is cube or 3. For example number 2, you have m to the 8th power. So our base is m. And our exponent is 8. For example number 3, so you have quantity negative 10c, close quantity to the 7th power. So our base is negative 10c. And our exponent is 7. After some review, let's proceed now with my main topic, which is the loss of exponent. Our first rule is product of powers rule. To multiply powers of the same base, copy the base and add the exponents. Example number 1. So we're going to multiply x to the p power multiply by x cubed or x to the 3rd power. Solution. So we're going to expand x to the p power, that is x times x times x times x times x multiply by x times x times x. So if we're going to add x to the p power and x to the 3rd power, so our answer will be x to the 8th power. So it means x to the p power multiplied by x to the 3rd power is equals to x to the 8th power. Example number 1. 3 squared multiplied by 3 cubed. So we're going to add our exponents. So our exponent is 2 and 3. So that becomes 5. So our answer is 3 to the p power. If we're going to expand 3 to the p power, that is 3 times 3, that is 9 times 3, 27, times 3, 81, times 3, that is equals to 243. Example number 2. So you have quantity 4x to the 6th power, y squared, then multiply by quantity 2x cubed y to the 4th power, that will be equal to, so we're going to multiply our constant 4 times 2, which is equals to 8. Then we're going to add our exponent for x. So x to the 6th power plus x to the 3rd power, so you have x to the 9th power. Then we're going to add the exponent of y, 2 plus 4, that is equals to 6. So our answer is 8x to the 9th power, y to the 6th power. If we're going to solve it in an expanded form, so we're going to expand 4x to the 6th power y squared. So you have 4, then mayroon tayong
6 na x at 2 y. Then, sa 2x cube y to the 4th power naman, mayroon tayong 2 at saka 3x, 4 na y. So, if we're going to multiply 4 times 2, that is 8. And then, if we're going to count all the x, so that is 9x. So you have x to the 9 power. Then, kung bibilangin natin yung y, mayroon tayong 6 na y, kaya 6. So our final answer is 8x to the 9 power, y to the 6 power. Example number 3. You have quantity 2a cubed b cubed c squared multiplied by quantity negative 3a squared b squared c cubed multiplied by 5abc. What we're going to do is we're going to expand first. So you have 2, then you have 3a, you have 3b, and 2c. Then you have negative 3, you have 2a's, 2b, and 3c's. Then you have 5abc. First, we're going to multiply our numerical coefficient. So you have 2 times negative 3 times 5, that is equal to negative 30. And then we're going to add all a's. So, kung bibilangin natin lahat na a, mayroon tayong 6 na a, at mayroon din tayong 6 na b, at mayroon din tayong 6 na c. So, our final answer is negative 30, a to the 6th power, b to the 6th power, and c to the 6th power. Next, we have the second rule. We have power of a power rule. To raise a power to the given power, multiply the two exponents and write the product as the exponent of the base. That is for our second rule. Let's simplify quantity x to the p power, close quantity to the 4th power. Expanded form. So we're going to multiply x to the p power 4 times. So you have x to the p power times x to the p power times x to the p power times x to the p power. Applying product of the power rule, so you have x, 5 plus 5 plus 5 plus 5. So that is x to the 20th power. Or simply multiply your exponent. So you have x multiply 5 times 4, that is equal to x to the 20th power. Example number 1. So you have quantity 4 cubed, close quantity squared. So in expanded form, that's 4 cubed multiplied by 4 cubed. Applying product of the power rule, so 4 cube plus cube, so equals 4 to the 6th power. If we're going to expand 4 to the 6th power, that's 4 times 4 times 4 times 4 times 4 times 4, that is equals to 4096. Or simply multiply your exponent. 4 raised to the 3rd power plus to the 3rd power, that is equals to 4 to the 6th power. And you have the answer 4096. Example number 2. Bracket quantity a plus b cube, close bracket, to the 7th power. Expanded form, so it means we're going to expand quantity a plus b, close quantity cubes. So, applying product of the power rule, so a or quantity a plus b, then we're going to add 7 times 3, that is equals to 21. So our answer is quantity a plus b, close quantity raised to the 21 power. Or simply multiply your exponent. So bracket quantity a plus b, close parenthesis cube, close bracket, to the 7th power. That is equal to quantity A plus B, then you multiply 3 times 7. Your answer is quantity A plus B to the 21st power. Example number 3. So you have quantity 8A squared B squared, close quantity squared. Another one, you have quantity 6A cubed B squared, close quantity squared. Let's solve that one in expanded form. So you have 8 squared A squared multiplied by squared B squared multiplied by squared, close quantity, then close bracket, 6 squared A cube multiplied by 2B squared multiplied by 2, close bracket. So 8 cube is equals to 64. Then A squared times 2, that's A to the 4th power. B squared times 2, that's B to the 4th power. Then 6 squared, that is equals to 36. A cube multiplied by 2, that's A to the 6th power. Then B squared multiplied by 2, that's B to the 4th power. Then multiplying 64 times 36, that is equal to 2,304. Then adding your exponent for A, that's 4 plus 6, so you have A to the 10th power. Then adding B to the 4th power and B to the 4th power, that becomes B to the 8th power. So our final answer is 2,304 A 10th power, B to the 8th power. Next is power of the product rule. To raise a power to a given power, raise its factor of the given product. Let's take a look with this example. Find the value of the quantity 5x squared y to the 6th power close quantity cube. So it means we're going to expand 5x squared y to the 6th power close quantity cube. So you have 5x squared y cube close quantity cube, that is equals to 5x squared y cube times 5x squared y cube times 5x squared y cube. Multiplying all our numerical coefficient, 5 times 5 times 5, and then you have x squared times x squared times x squared. So, mayroon tayong 6 na x at y cube times y cube times y cube. Mayroon tayong 9 na y. Multiplying 5 times 5 times 5, that's 125. Then counting all your x, that is x to the 6th power. Then counting all your y, that's y to the 9th power. Or you have 5 or quantity 5x squared y cube close quantity cube, that is 5 cube times x squared times cube y cube multiplied by cube. So our final answer, 5 cube, that is equals to 125, then x to the 6th power, y to the 9th power. Example number 1, you have quantity 10 f to the p power d squared close quantity squared. So we're going to expand 10 f to the p power d squared close quantity squared. So you have 10 f to the p power d to the 2nd power, then 10 f to the p power d squared. Then 10 times 10, that will be equal to 100. Then mayroon tayong f to the p power times f to the p power. So mayroon tayong 10 f. Then mayroon tayong d squared times d squared, which is mayroon tayong 4 na d. Then we multiply 10 times 10, that is equals to 100. Then mayroon tayong 10 f. So you have f to the 10 power. Then mayroon tayong 4 na d, kaya d to the 4th power. Or 10f to the p power d squared close quantity squared. So you have 10 squared f 5 times 2, then D, 2 times 2. For our final answer, so you have 100F to the 10th power, D to the 4th power. Example number 2. So you have quantity 3m squared, n to the p power p, closed quantity cube. So it means we're going to multiply our base 3 times. So if we're going to expand our example number 2, so you have 3m squared n to the p power p multiplied by quantity 3m squared n to the p power p multiplied by 3m squared n to the p power p. Applying product of the power rule, so you have 3 times 3 times 3, that is equals to 27. Then adding all our m squared times m squared times m squared, so you have m to the 6th power. Then adding all our exponent for n to the p power and times n to the p power times n to the p power, so you have n to the 15th power. And then you have p times p times p, so you have p to the 3rd power. Or simply multiply your exponent. So you have 3 cubed, which is equals to 27. Then we multiply m squared times 3, then n times 5 times 3, then p times 1 times 3. So for our final answer, so you have 27 m to the 6th power n to the 15th power p cubed. Example number 3, quantity negative 2p to the 4th power q to the p power closed quantity cube. To solve the problem, let's write it in expanded form. So we're going to multiply negative 2p to the 4th power q to the p power thrice. Then multiply all our numerical coefficient, negative 2 times negative 2 times negative 2. Then expand our p to the 4th power. So meron tayong 4 na p plus 4 na p, then 4 na p. So bali meron tayong 12 na p. Then q to the p power plus q to the p power plus q to the p power. So mayroon tayong 15 na q. So for our final answer, negative 2 times negative 2, that's positive 4, times negative 2, that is negative 8. Then counting all our p, so you have p to the 12 power, then q to the 15 power. Or the quantity negative 2p to the 4th power, q to the p power, closed quantity cube. So negative 2 cube, that is equals to negative 8. Then you have p 4 times 3, that is p to the 12 power, then q to the p power times 3, that is q to the 15 power. So our final answer is negative 8p to the 12 power q to the 15 power. Next is quotient rule. For every positive integer m and n and a is not equal to 0, if the exponent of the numerator is greater than that of the denominator, then a raised to m divided by a raised to n is equals to a raised to m minus n. That will be our formula. Simplify the following. 5 to the 9th power divided by 5 to the 5th power. So we're going to expand 5 to the 9th power. So we have 9 5s for our numerator. Then for our denominator, 5 to the 5th power. So you have 5 5s. And then we're going to cancel out 5 5s in the numerator and 5 5s in the denominator. The remaining numbers are 5 times 5 times 5 times 5, or 5 to the 4th power. So 5 to the 9th power divided by 5 to the 5th power, that is equals to 5 raised to the 9th power minus 5, which is equals to 5 to the 4th power, or equal to 5 times 5, which is equals to 25, times 5, 125, then times 5. Our final answer is 625. Next, if the exponent of the denominator is greater than that of the numerator, then a raised to m divided by a raised to n is equals to a raised to m minus n. So that is equals to 1 over a raised to m. 9 to the 6th power divided by 9 to the 9th power. So we're going to expand 9 to the 6th power, that is 6 nines. And then for our 9 to the 9th power, that is 9 nines. Then we're going to cancel 6 nines in our numerator and 6 nines in our denominator. Then we're going to have 1 over the remaining 9s in our denominator, 9 times 9 times 9, which is equals to 729. So our final answer is 1 over 729, or 9 to the 6th power divided by 9 to the 9th power, that is equals to 9 to the 6th power minus 9, which is equal to 9 raised to the negative 3, which is equal to 1 over 9 to the 3rd power. And for our final answer, so we have 1 over 729. For the third one, you have if the exponent of the numerator and the denominator are equal, then a raised to m divided by a raised to n is equal to a raised to m minus n is equals to a raised to 0, which is equal to 1, because any number raised to 0 is equal to 1. Note, to divide powers of the same base, copy the base and subtract the exponents. To raise a power to a given power, raise its factor of the product to the given power. Example, so you have 12 to the 6th power divided by 12 to the 6th power. Then if we're going to expand that one, we're going to write 12 6 times in our numerator and 6 12 also in our denominator. So then it means we're going to divide both sides. The result will be 1 divided by 1. So 1 divided by 1 is equals to 1. So dividing the same base and exponent, so our final answer is 1. Example number 1. So b to the 17th power divided by b to the 10th power, that is equals to b to the 17th power minus 10, that is equals to b to the 7th power. Example number 2. 63x to the 10th power y to the 5th power divided by 7x to the 9th power y to the 3rd power. First, we're going to divide our numerical coefficient, which is 63 divided by 7 is equals to 9. Then we're going to subtract our exponent. So 10 minus 9, that is equals to 1. And then we're going to subtract y to the 5th power, then y to the 3rd power. So you have 5 minus 3. So you have y squared. So our final answer is 9xy squared. Example number 2. You have 18b to the 11th power c to the 8th power divided by 20b to the 7th power c squared. So, we cannot divide 18 by 20. So what we can do is, we can just write or divide both sides by their GCF, which is equal to 2. So 18 divided by 2 is equals to 9. Then 20 divided by 2 is equals to 10. Then we're going to subtract our exponent, 11 minus 7, and then you have 8 minus 2. So our final answer will be 9 over 10, b to the 4th power, c to the 6th power. Next, we have the next rule, power of the quotient rule. To raise a fractional expression to a power, raise the numerator to the power and divide by the denominator raised to the same power. Now, let's simplify example number 1. So you have quantity x over b, closed quantity raised to the 9th power. So we're going to apply power rule. So you have x to the 9th power divided by b to the 9th power. So we cannot divide x to the 9th power over b to the 9th power because they have different base. So our answer will be x to the 9th power, b to the 9th power. Example number 2. So you have quantity 2x divided by 4, closed quantity cubed. So it means we're going to expand 2x over 4 thrice. So you have 2x over 4 multiplied by 2x over 4 times 2x over 4. And then multiply. So you have 2x times 2x times 2x, so you have 8x to the 3rd power divided by 4 times 4 times 4, which is equals to 64. Then we can reduce our fraction 8x cubed divided by 64 by dividing both sides, the numerator and denominator, by 8. So 8 divided by 8 is 1. And 64 divided by 8, you have 8. So our final answer is x cubed over 8. Example number 1. So you have quantity 5 divided by 10, closed quantity to the 4th power. So you have applying the power rule, so you have 5 to the 4th power divided by 10 to the 4th power. Next is expanding 5 to the 4th power, which is 5 times 5 times 5 times 5. Then expanding 10 to the 4th power, that is 10 times 10 times 10 times 10. And then multiplying 5 times 5, that's 25 times 5, 125 times 5, 625, divided by 10 times 10 times 10 times 10, that is equals to 10,000. Then finding the GCF, which is 625, so we can divide both sides, the numerator and denominator, by 625. So 625 divided by 625, that is 1. And then 10,000 divided by 625, that is equal to 16. So our final answer is 1 over 16. Example number 2. So let's say you have 4x to the p power y to the 8th power divided by 2x squared y cubed, closed quantity cubed. So it means we're going to apply power to power rule first. So 4 cubed x to the p power times cube y to the 8th power times cube over 2 cubed x squared times cube y cubed times cube. So simplifying 4 cubed, that is equals to 4 times 4 times 4, that is 64. Then x, 5 times 3, that is 15. Then y, 8 times 3 is equals to 24. Over 2 cubed, which is 2 times 2, 4 times 2, that is 8. Then x, 2 times 3, that is 6. And then y, you have 3 times 3, that is y to the 9th power. Then applying division rule, so you have 64 divided by 8, that is 8. Then 15 minus 6, that is 9. Then 24 minus 9, that is 15. So our final answer for example number 2 is 8x to the 9th power, y to the 15th power. An addition rule in solving exponents is that the final answer should not contain any negative exponents. Aside from that, any expression raised to 0 is equal to 1, except for 0. Next is a negative exponent rule. If a raised to negative x, that is equal to 1 over a raised to x, where a is not equal to 0. Example number 1. X raised to the p power divided by x to the 10th power. That is equal to x to the p power minus 10. And that is equal to x raised to the negative 5 because negative 10 is greater than positive 5. Removing our negative exponent for x raised to the negative 5, ang kapalit ni negative ay 1 for our numerator and just copy x to the p power. Example number 2. 10 to the 8th power divided by 10 to the 12th power is equals to 10 raised to the 8th power minus 12. That is equals to 10 raised to negative 4. Removing our negative exponent, that becomes 1 over 10 to the 4th power. Simplifying 1 over 10 to the 4th power, our final answer will be 1 over 10,000. Example number 3. N to the 2nd power, p to the p power, divided by n to the 4th power, p to the 3rd power. That is equal to n raised to the 2nd power minus 4, p to the p power minus 3. So our answer is n raised to negative 2, p raised to the 2nd power. That is equal to, since n raised to the negative 2, that will be our denominator. So n to the 2nd power. And our p squared is positive, so therefore that will be our numerator. So p squared divided by n to the 2nd power, or n squared. The next rule is zero exponent rule. If a raised to 0, then a raised to 0 is equals to 1, where a is not equal to 0. Example number 1. 13y to the 0 power, that is equal to 13, multiplied by y raised to the 0 power. So therefore that is equal to 13 multiplied by 1. So our answer is 13. So 13y raised to 0 is equals to 13. Example number 2. 25m to the p power, p to the 8th power, closed quantity raised to 0. So you have equals to 25 raised to 0 times m to the p power times 0 times p, 8 to the 8th power times 0. So it is said that any number raised to 0, so you have 25 raised to 0 equals 1. Then you have m, 5 times 0, that is 0. Then p, 8 times 0, that is p raised to 0. So therefore, 1 times 1 times 1, our final answer is 1. Example number 3. 7y to the 5th power divided by 11z to the 8th power closed quantity raised to the 0 power. So distributing our power 0, so equals to 7 raised to 0, y to the 5th power times 0, divided by 11 raised to 0, z raised to 8 times 0. So you have 7 raised to 0 is equals to 1, and then you have y raised to 5 times 0, that is equals also to 1 over 11 raised to 0, that's equal to 1 times z 8 times 0 is equals to 1. So 1 times 1 is 1, then 1 times 1 is also 1. So 1 divided by 1, our answer is also a 1. Hello mga batang mandunong, nakasunod ba? Sana marami kayong natutunan sa video presentation ko ngayon. Thank you so much, Mr. Restituto I. Rodelas, for this another opportunity. Kaya kung nagustuhan ninyo video ko, lalong-lalo na ang mga mabait at masisipag na mag-aaral ng Ilaya Barangka Integrated School, i-like, subscribe, and share na. Sa Pavlovian Angels at sa parents nila, Periodnatics, Maslonians, Kohlbergians, Brunerians, and Gardnerians, thank you for your support. Again, this is Sir Jomy D. Yucampo of Ilaya Barangka Integrated School. Once again, thank you for watching.
And that ends our Week 5 advanced lesson for Grade 7. If you have questions, you may send a message for our official page, Team Mathematics Teachers Associations of Mandaluyong, or you may send a message to Mathematics Teacher. Thank you. Math-sayang Math-aral ng Math-tuto.